quicker we get done today, the quicker we can have more time to hand stuff back. Because I have a ginormous stack of stuff to hand back. Alright. So, happy International Sweater Vest Day. Alright, let's do this. So, we wrote this up a couple of years ago, then we edited it a couple of times since then. But, so we're starting a new chapter, new unit. This is in the old book, this was chapter 5. And chapter 5 covers identities, solving trigonometric equations, proving trigonometric identities, more identities, law of sines, and law of cosines. Okay? So this unit, if you will break up into 3 different parts. Okay? So the first part we're going to deal with is going to be identities, some basic identities, some solving trigonometric equations, and proving trigonometric identities. That we're going to do before winter break. Okay? If you think about it, you really only have 12 pre-calc classes until winter break. Okay? And so we updated the schedule in the back actually before Thanksgiving break. So that's what it's going to be. So if you look at it, we're teaching Monday, Tuesday, or excuse me, we're teaching Tuesday, Wednesday, Thursday. We're taking a formative on Friday. Next week, Tuesday, Wednesday, Thursday, we're teaching. We're taking a formative on Friday. Week after, review, test. And then that gives us the Friday to do a holiday activity before break. Okay? So, in this chapter, we're switching our emphasis towards more theory and proof. So we're going away from actual, like, 2 plus 2 is 4, to y is 2 plus 2, 4. Okay? And it's going to be more theory and more proving, and you're going to have to, even when we get into, like, the law of sines, the law of sines isn't as nice and neat as it was when you guys had it in geometry. Okay? So there's ambiguous cases for the law of sines, and we have to prove that those are there and then find them. Okay? Exploring where the properties of these special functions lead us, often with no immediate concern for the real-world relevance at all. I cannot say today, you are going to, what I mean by that is, I cannot say today, where are you ever going to use secant of negative x times cosine of negative x? Okay? That's not my worry today. I'm not worried about where you're going to use this in life. I'm worried about the theory and the finding and the mathematics behind simplifying that today. Okay? We hope that in the process to give you an appreciation for the rich and intricate tapestry of interlocking patterns that can be woven from the 6 basic trig functions. Patterns that will take on an even greater beauty later on when you can view them through the lens of calculus, which is true. The title of this class is pre-calculus. Okay? This unit, the mini unit before winter break, is all about getting you ready for your next calculus class. Okay? Yeah. So let's dive into it. I handed out to you a purple unit or a trig identity sheet. On the front side are 25 trig identities that we will be going through over the course of the next month and a half. Okay? Right? We will get to all of those on there. If you flip it over, you're welcome. Okay? So you have that there for you too. When it comes to formative, I shouldn't say this formative on this week Friday. Shoot, I should have put that in there for this week Friday. Oh well, that's okay. That's right. When it comes to formatives, you will be able to use this sheet. Okay? When it comes to the test, we will give you your own, or we'll give you a laminated copy of it for you to use in class. Okay? So you can write whatever you want on yours, okay? But for tests, you will only get the blank copy, just so you know. Okay? You can, if you wanted to use this, if you're thinking ahead to middle of January, because let's be honest, it's really not that far away. If we're thinking in terms of days of school, your final is in 5 weeks. Okay? In terms of school, it's in 5 weeks. In terms of actual days, it's still 2 months away. Okay? But in terms of school, it's really not that, in terms of school days, it's not that far away. Okay? So, you can start using, you can write whatever you want on this. If you choose, we decided this yesterday, if you choose to use this as your note sheet for the semester 1 final, that's great. More power to you. Okay? If you choose to make your own separate sheet, that's great. More power to you. You will only get one extra piece of paper. You can't make another note sheet and then use this sheet at the same time. With me? Okay? So that's if we're looking ahead to that. Okay? Let's do this. Love this stuff. Okay? So, a couple of things to remember from way back in, mid-September. Okay? Cosine is cosine. Okay? Sine is sine. Okay? Secant is the reciprocal of cosine. Yes, we're having to go over this because some people still don't understand that secant is the reciprocal of cosine. I've said it 1,000 times. Everything needs a co. Everything needs a co. So secant goes with cosine. Cosecant goes with sine. Okay? You can't express that enough. It's going to come into play numerous times. Okay? Tangent is sine over cosine. Cosecant is 1 over sine. Cotangent is cosine over sine. You should have those memorized by now. Some of you still don't. Okay? That's just facts. Okay? I corrected your tests. It's facts. Okay? All right? So, and then you got the big one. You got the hammer. This is going to be your bread and butter in the next 2 weeks for sure. Sine squared plus cosine squared, or cosine squared plus sine squared is equal to 1. That is the hammer. We learned that back in the obviosities. Okay? All right? Now, that can be rewritten as it is rewritten in number 7 on your identities sheet. That can be rewritten as cosine squared is equal to 1 minus sine squared. Whoa, there it goes. Sine squared is equal to 1 minus cosine squared. Okay? So those are some identities. With me? Okay? In the obviosities that we learned already, we also learned numbers 1 through 6. Okay? Those are the negative angle identities. So cosine of negative t is equal to cosine of t. Sine of negative t is negative sine of t. Tangent of negative t is negative tangent of t. That's 1 through 3. And so on and so forth with secant, cosecant, and cotangent for numbers 5 and 6. 4, 5, and 6. Okay? Refer back to that. You will need your notes out. I see that nobody's gotten their notes out, even though we're almost 10 minutes into me giving notes. Okay? So, let's talk about the hammer. Cosine squared plus sine squared, or sine squared plus cosine squared is equal to 1. What is going to happen if we take the hammer and we divide it by sine squared? So if I take the hammer and I divide everything by sine squared of theta, is that legal? Mathematic-wise, is that legal? Why not?
You can't just divide a sign off of something, you have to do the inverse sign for the inverse thing. Is that what you're talking about?
No, I'm asking if I can divide every single term in that, if that's legal by sine squared. Is that legal? I'm talking mathematical legal. I don't know why it keeps going off, why the screen keeps going blank. Is that mathematically legal? Yes, because why? Because I divided both sides and I divided every single term by the same thing. Okay? If I would only have done sine squared on one of them, it's not legal. But because I did it everywhere, mathematically, it is legal. Okay? So let's look here then at sine squared divided by sine squared. What is that? That's 1. Let's look at cosine squared divided by sine squared. What is that? Not cotangent. Cosine squared divided by sine squared. It's cotangent squared. Let's look at 1 divided by sine squared. Cosecant squared. Which, if I'm not mistaken, is identity number 10. Okay? On your identity sheet. This is starting to annoy. This whole blackened screen every once in a while. Now. Okay? Alright? So that is identity number 10. Okay? Which now we can use. What if we would do that by divide by cosine squared? First off, is it legal for me to do divided by cosine squared? Divided by cosine squared divided by cosine squared. Is that legal? Yep, because I did it everywhere. Okay. First one, sine squared divided by cosine squared. Tangent squared. Cosine squared divided by cosine squared. One divided by cosine squared. This is identity number 11. So out of the hammer, we also developed not only the 3 in number 7, the 3 versions of the hammer, okay, but we also developed 2 extra ones by dividing all of them by cosine squared and dividing by sine squared. Okay? So where are we going with this? We are going to give you a trigonometric expression, much like secant of negative x, cosine of negative x. or secant squared of x minus tangent squared of x. We're going to give you these mathematical expressions, and we're going to simply say, simplify. Okay? And you're going to have to simplify that down until you can't simplify that down anymore. Okay? Things to look for. First off, if you look at your sheet, your identity sheet, first off, anything that's on that is an identity, probably means you can simplify it then. So when you see a negative angle, that's all on there. Okay? When you see a squared, that's numbers 7, 10, and 11. Okay? Definitely want to simplify those. Okay? Okay? So let's jump in. Secant of negative x. Do we have an identity on our sheet? If so, which number is secant of negative x? Number which one? Number 4? Okay, so secant of negative x would be equal to secant of x. Cosine of negative x is equal to, and if so, which number? Number 1, what's it equal to? Cosine of x. Okay. Secant. What is secant equal to? What was that? 1 over cosine of x? One over cosine of x? 1 over cosine of x times cosine of x. Cosine of x over cosine of x, which is just 1. So we simplified that all the way down to just 1. So, my question to you is this. What are we really grading? If this were a formative this week Friday problem, if this were a formative next week Friday problem, if this were a test in 2 weeks problem, what are we really grading? We're grading your work and your steps and your process. Okay? The answer is irrelevant. I shouldn't say the answer is irrelevant because the answer does matter. But if this were a 2-point problem, I would probably grade the answer as a half of a point. So my statement here is this: if the majority of the grade is the work, what do you need to show? The work. Okay? You cannot get by in the next 8 weeks of pre-calc. You cannot get by with not showing your work. Okay? Right? No work means nothing. Means you get 0, zilch, nada. Okay? Right? And then you're going to complain to me. I showed the answer. Great. Nothing. Okay? Alright? You gotta show your work. Okay? Secant squared minus tangent squared. Do we have an identity for either one of those two? We have one for secant squared. Which number?
11.
Number 11. Okay? So secant squared is equal to tangent squared plus 1. So what does this simplify to be?
What?
1. Okay. Now, your work might be that easy. But if you do that in your head, you get nothing. If you write it down, you get everything. Okay? I can't stress that enough. Okay? You have to show your work on all of these problems. Try those two. I got sine of x for the first one, and I got cosecant of x for the second one. Questions?
Would we have to write out the step of like cosine x over cosine x?
The pink step?
Yeah.
Not necessarily. But I would here, not necessarily. I would allow that one to be skipped. This one I would allow. This one I wouldn't want to see. Okay. Yeah. Because you could have just done this. Yes.
Yeah, I see that.
Right from there. Try those two. So you could do number 5 in a couple of different ways. Okay? You could distribute your sine first. Okay? You could simplify what's inside the parentheses first. Okay? All depending on whatever you want to do. I'm going to distribute the sine first. Okay? Because then I get sine of theta cosecant of theta minus sine squared of theta. Sine of theta cosecant of theta is sine of theta times 1 over the sine of theta, which is just 1. So that this becomes 1 minus sine squared of theta. 1 minus sine squared of theta is an offshoot of the hammer, and that is cosine squared of theta. It's in number 7 on your identities sheet. Okay? Again, it is not your... I'm trying to think of the word to say here. You don't have to pick a path or guess which path we want you to take. Okay? There's multiple different paths to get to the answer. Okay? that job's on me to follow your logic on how to do it, or how you did it, okay? And if your logic is flawed, then I'm gonna ding you, okay? And I'm gonna point out where your logic went sideways, okay? But your logic could take you 18 different directions. As long as we can follow it, we're good, okay? 1 minus cosine squared, that's in number 7 also. That is sine squared of x. Cosecant is 1 over sine of x. So that gives me sine squared of x over sine of x, which just simplifies down to being sine of x. Questions, comments, concerns? 3 more. Try those 2. Cosecant is 1 over sine. Secant is 1 over cosine. Little keep change flip action says that this then is going to be 1 over sine times cosine over 1, which is going to be cosine of theta over sine of theta, which is cotangent. Questions on that one? Tangent squared plus 1 is secant squared. Secant squared is 1 over cosine squared. Cosine squared times 1 over cosine squared is just 1. Good? No questions? Sometimes we might have to simplify with factoring first. Okay? What can I factor out of this one? What? A sine of x, exactly. I can factor out a sine of x. If I factor out a sine of x, what's left over? 1 minus cosine squared. One minus cosine squared is?
Sine squared.
Sine squared. Sine of x times sine squared of x is sine cubed of x. So I just handed out your homework packet to you. in said homework packet, you have the ability to do numbers, I would say 1 through 16. Maybe you won't be able to do numbers 13 and 14, but you can look at your identity sheet and figure those out. But yeah, definitely 1 through 16 can be done.